Hello YouTube viewers, welcome to my show Camera Tuesday. In today's episode we're going to discuss about XLR connectors or balanced output. So let's dive right into it. Now first thing you have to understand, before we created this extra hoo-ha, why the hell we needed it, what was the issue. Now in simplest physics term, you have to understand every cable, every conductor that is, no matter how long, no matter how thick, how short, it is an antenna to some spectrum. Basically if you have a long one, it will work with the certain spectrum. If it's a short one, it will work with certain standards. So everything, every conductor is susceptible to electromagnetic spectrum. Some may be susceptible to basically microwave, high frequency microwave. Some would be susceptible to low level, basically FM radio. But you have to understand every conductor is susceptible to it. Then we come to another aspect. Now every conductor that is carrying electrical current one way or the another, like it's taking from point A to point B or point B to point A, it is susceptible to electromagnetism also. So that is electromagnetic field, and this is MF, basically magnetic field. It's also basically possible to be interfered by it. Why? Basically think of this, you must know this rule. Basically if you have current, then you have magnetic field. Now you are carrying charge or signal from point A to point B. Now it is creating a magnetic field. But if you have, let's say, something like a power supply next to it or somewhere in along the line where the power cable is going, it will generally have a much bigger power signature. It will generally have much bigger things that generate much bigger magnetic field, stronger magnetic field, that will directly interfere with the cable's magnetic field, and that will cause us degradation of signal quality. Now all of this is not an issue if you are only making something small, like from this to recorder. It's not gonna make that much of a difference. However, the longer the cable, basically if you are talking about 2 meters, 3 meters or 10 meters, the longer the cable, the more problematic it becomes. Now imagine it this way. Let's say you are a cameraman holding a camera and the microphone is connected, something like this, and basically a news anchor is talking like this. Now here's that distance may be like 1 meter, that distance may be 3 meter or 4 meter, or maybe the cable is extra long just for in case like you have to go to somewhere or something like that, or cameraman wants to be stay far apart, so it gets more of a wide field. So in those sort of scenario, you cannot like always rely on having a small cable. You must have longer cable. And let's say somebody is doing stage performance, the cable length has to be ludicrously huge, and you might be like, why not use wireless? Again, wireless is good and all that, but imagine it this way. A concert mic can keep running for like 8 to 9 hours, or sometimes even 12 hour concerts is possible. So in those sort of scenario, wireless microphone is not a very good idea, and wireless is a new technology. So in those sort of scenario, having a long cable makes your cable itself, not the microphone, cable itself susceptible to, basically it's creating a signal. Let's say the signal quality is 90% from the microphone. By the time it reaches the end, basically where your recorder is, the signal quality would have dropped to 50%. That is flat out unacceptable. So for this reason, we had to create something that can handle this situation. So the longer the cable, the more headache it becomes. So what was the solution? Now solution is basically what we classify as balanced audio. You must have heard this, like this microphone has balanced output, this recorder can accept balanced system. So what the heck that means? Now think of it this way. Somebody came up with a very clever idea. Is basically you take your microphone, in the microphone, I'm not talking about in the recorder, basically you take the microphone, you have a basically capsule that is taking the analog signal, basically my voice, and converting it into a basically electronic signal. So basically there is a spectrum to it, not spectrum, wave, basically a AC current kind of wave is there, positive and negative, positive and negative. Somebody came up with the idea, what if we create an inverter chip in this, basically, and the inverter, I'm not talking about AC to DC kind of inverter simply it's gonna phase shift it. So basically if you have a signal that is going up and down, you're gonna create a reverse signal, basically 180 degree apart, or inverted signal. That way if you mix both of them, basically you have two cables and both of them have this signal, the moment you mix it, the signal will become zero. So benefit of that is basically you take the microphone, you add you clone the signal, whatever signal you are getting from the capsule, you clone it. In that clone you create a one inverter circuit which inverts the signal, basically the waveform gets inverted. Then you come to the receiver simply says is I'm going to take the inverted signal and invert one channel of it. Now benefit of that, the moment you invert it, you get the same signal. But if any interference, any spectrum that was unbalanced, anything that was introduced interference in the cable happened, it would happen exactly the same. Basically it would be in phase. This is what we call common mode rejection. Basically any interference happen in the cable will not be out of phase. Basically interference is not like, okay, I'm gonna interfere this cable 180 degree apart. It's not gonna do that. Interference is gonna interfere. So interferes both of them simultaneously. So interferes, basically the noise signal gets exactly carried away. The moment you have two cable that carries exact same signal, during the inversion period it automatically cancels it out. and we have sent the signal in inverted already, so it won't cancel out. That's the whole point. That's the trick. That's why we use two inverters. So inverters on your microphone end and inverter on basically the receiver end, or sometimes it's classified as subtractor. So benefit of that is basically flat out rejects anything, any signal, any interference was created through the cable. Basically cable becomes 100% immune to any interference, and the benefit of this is it's automatic. Basically if you have a very large spike, it will handle it. If you have a lot of small spike, it will handle it. If you have something randomly coming on and off, it will handle it, because it's doing it in a mathematical sense. Basically you have a minus minus a, so 2 minus equals positive, so you end up with a 2a. So that is happening here. This is the intelligence part about it, which is classified as differential signaling. So you basically take one waveform, you invert the waveform, you send it, and you tell the computer, hey, it's inverted, invert the second channel and then connect it. But if you find something that is, let's say, interfered due to cable, basically magnetic field interference, it won't be out of phase. That is how we can send cable signal very far. On top of that, the cable that itself is there may be vulnerable to something very large that flat out distorts the signal. So to protect against that, we employ shielding cable, basically like how you have SDI cables. So those cable, you will have a shielding. This will act as a ground conductor, and this also protects if you have very long conductor, especially with alternating current, it acts like a capacitor and you have to discharge it. So this acts as that. That's why we have a third independent ground, primary ground. This ground will be connected to your microphone's metal body, to your recorder's metal body, to the grounding of your building. If it's not done properly, you may get electrocuted. So we have a completely independent shielded cable which is acting as a primary ground. Then you have twisted pair. So because I already said you have to have two audio signal, that's also twisted. So not only we have shielding from outside, where the cable itself is twisted, and even if, like, these are the passive barriers, even if something interferes in it, the differential signal will flat out eliminated. That's how professional audio works. This is why we classify as balanced audio. So no matter what you do, now of course within reason, like you're gonna put a MRI machine next to it, of course it's gonna interfere, or it will simply distort the signal. Basically signal won't pass through it, so you can have that. That is why we use 3 conductor design. Basically you have one ground, you have basically 2 audio, one of them would be primary. So whenever you find something like that converts your XLR to something normal, that is generally bypass, just letting go of the second one. So this is why nobody recommends you use this sort of adapters, basically, unless it's a 3 conductor adapters. Basically it's a balanced one, they don't recommend you, because if you are not using a balanced one, that simply means you are sending away, basically just rejecting half of the signal strength. So that is why it's not recommended. If you want to connect, let's say, XLR microphone to your computer, generally it's advisable to do through a proper interface that accepts a balanced XLR input. So this is how we create it. Basically we take the signal, we create an inverted signal, tell the receiver, hey, that one signal would be inverted, invert it again and combine it. During this time, during the transition, any interference that is caused would be caused equivalently to both of line, hot line and cold line, and during the inversion process it will be automatically rejected. And we have grounding to protect against anything major capacitor related hoo-ha, and you have to have 3 conductors. That is why professional XLR cables are so expensive, because cheap ones generally skip on the twisted pair. So what about XLR? Okay, XLR, you have to understand, is created by George Q. Cannon. Yes, his name is Cannon. The Cannon family is apparently there. He created it in 1950. So it's an old system. It's a very time-tested experience. Like it knows its thing. So it is generally started from day one. It was started with 3 systems. However, you have to understand this. At the early day, that is why it's 3-pin, but it's still mono. 3-pin in basically headphone terms means you're gonna have basically one ground, and you're gonna have a stereo left, stereo right. Now that way you get a stereo signal, but in microphone the ground pin is there, first ground pin, and then you're gonna have one signal. Now this 2 can work as it, but you won't get the balance output. You have to have the third 180 degree out of phase one. So during this thing you only get mono signal. Even though you have 3 conductors, you only get mono signal. This is very critical. Do not assume like this allows you to have stereo output. And the way the conductor is designed is very clever. It's like it will always make connection no matter what you do. Basically you take it and you connect it like this, it will make the connection with grounding first. This is reason. So grounding can be done, and you won't, if you connect it live, basically let's say a recorder is working and you connected it, won't have bing, you don't gonna get that large spike. That is why grounding has to be connected first. And the system is designed for professionals, so that's why it always has a locking system. You cannot just basically pull it, no matter how hard you pull. Of course you're more likely to break the connector than need to actually pull it out, because it has a locking system. And on top of that, there are many variations of this. When you say XLR, you have to say simply XLR. If you say mini XLR, you're gonna get something that was created for lavalier microphone. You may get something that had like 5-pin XLR. These are generally used for headphones. Or sometimes you may get something that was used, even though it is same, it will look exactly same as this, it was used for lighting system, sound system. So you have to be a bit more careful, but generally this is what XLR is, a balanced system. Basically you take two conductors, you send one offset, and then you have a third conductor that's acting as a ground pin, and the plug, basically the plug, male and female, is designed in such a way that it makes the ground connection first. This is crucial, otherwise it will, every time you do it live, swap in and swap out, it's gonna bjing bjing, it's gonna do that. So this was XLR. So this was my presentation on XLR or balanced audio. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, don't worry about it. I would urge you to press dislike, and I would urge you to press this twice to show me your extra disappointment. And please leave a comment because I reply to all of them. Press subscribe, press the bell icon if you're free, and as always, thanks for watching.